All right, today we're going to dive into one of the most powerful tools in all of organic chemistry, the aldol condensation. Seriously, this reaction is a cornerstone for building big, complicated molecules out of smaller, simpler ones. It's kind of like molecular Legos. So let's get into it.
So it all starts with this big question, right? You look at these incredibly complex structures, like the medicines that save lives or the advanced materials in our gadgets. How on earth do chemists actually build those things? How do you take simple stuff and construct these intricate carbon frameworks with such incredible precision?
Well, the secret sauce really is a toolbox of reactions. And the most powerful tools in that box are the ones that can create new bonds between carbon atoms. I mean, this is the absolute heart of organic synthesis. It's how you build anything bigger, anything more complex.
And that brings us to the star of our show today, the aldol condensation. At its core, it's a reaction where this really reactive thing called an enolate ion goes and attacks another carbonyl compound, like an aldehyde or a ketone. And the result? Boom! You get a brand new, super useful carbon-carbon bond linking those two molecules together.
Okay, so to really get this, we're going to start with the classic, the standard aldol reaction. Let's really get our hands dirty and walk through the mechanism step by step.
So here's the simplest case you can imagine. Two identical molecules of acetaldehyde. You put them in a flask with a base, and they join forces to create this new, bigger molecule. And check out the product's name, an aldol. That's a huge hint about its structure, because it has both an aldehyde group and an alcohol group. Pretty clever, huh?
Now, the magic that makes this all happen really boils down to three key steps. First, we got to form that enolate. Then, the enolate does its thing and attacks. And finally, a quick protonation cleans everything up. So let's break each of those down. Step 1 is all about enolate formation. A base, like hydroxide, floats along and snags a hydrogen atom. But not just any hydrogen. It takes one from the carbon right next to the carbonyl group. We call this the alpha hydrogen, and it's a little bit acidic. Once it's gone, what's left behind is this negatively charged, superreactive species called an enolate. This guy is our attacker.
And that brings us to step 2, nucleophilic attack. The enolate we just made is a powerful nucleophile, which is just a fancy way of saying it's looking for something with a positive charge. And it finds one on the carbonyl carbon of a second molecule of acetaldehyde. So the enolate attacks that carbon and bam, that's it. That's the exact moment the new carbon-carbon bond snaps into place. This is the whole point of the reaction, right here.
Okay, on to step 3, protonation. After that attack, we're left with this negatively charged oxygen, an alkoxide. It's not super stable like that, it's not happy, so it immediately grabs a proton from a nearby water molecule. This neutralizes the charge and gives us our final, stable aldol product, with its signature aldehyde and alcohol groups. Job done.
So you might be wondering, why is it called a condensation? Well, a lot of the time, the reaction doesn't stop with the aldol. If you add a little heat, a molecule of water gets kicked out. It condenses out of the molecule.